this main equation up here at the top, we've talked about that on each of the conics we've done. Circles, we said that A and C must both be positive and the same number. For ellipses, A and C must both be positive but different numbers. And then today, for hyperbolas, A and C must be different signs. So one must be positive and one must be negative. That's what determines whether it's a hyperbola. Doesn't matter if they're the same number, different numbers, but their signs must be opposite. So again, when you see an x squared and a y squared, if you see the number in front of them is exactly the same and they're positive, then it's a circle. If A and C are both positive but different numbers, then it's an ellipse. If A and C are different signs, then it is a hyperbola. And so here are the standard equations for hyperbolas. We have horizontal and vertical, just like we did for ellipses. Okay, I'm going to compare a lot of stuff to ellipses today so that you can tell the difference on Thursday when you have your quiz. So notice that for horizontal and vertical, the a squared and the b squared are in the same place, whereas ellipses, the a squared and the b squared were flip-flopped. Okay, the x and the y are what are flip-flopped for hyperbolas, and this is what I expect it to look like when it's in standard form. The positive term is always going to be first. So if the first term is positive and it's x and then minus a y, notice it's going to be a horizontal. And let's think about that. X moves horizontally. As you increase or decrease the x, that moves left and right. So if the x is first, it's going to be horizontal. For the vertical, y moves up and down, which is vertical. So if the y value is first and it's positive, then it's going to be a vertical hyperbola. Ellipses, we said that a squared is always the bigger number. Hyperbolas, a squared is first. Okay, it's going to be under the positive term in the numerator. So a squared is first. Doesn't matter if it's bigger or smaller. That was only ellipses. Ellipses, we said a squared is the bigger number. Hyperbolas, it's first. Doesn't matter if it's bigger or smaller. The asymptotes are going to be the dashed lines that go through the center of the hyperbola, and that's kind of how you draw your hyperbola, is through the asymptotes. So just like last year, they're going to be dashed lines, and those do have to be part of the actual graph. You can see the picture below all that stuff. It shows those slanted lines that are asymptotes. The h and the k you just get from the center. So this y minus k just comes down here, whether it's vertical or horizontal. This x minus h, take away the squared, just comes down here. The plus or minus, because they cross, one's positive and one's negative, and then you find the slope. Lots of different ways you can find the slope. Slope is rise over run. A lot of times it's the easiest to draw the picture and then just count. Or if you like memorizing things, the slope for a horizontal is going to be b over a. The slope for a vertical is going to be a over b. Okay, so you can remember that. If you like to memorize things and that's what you're good at, you can memorize that for each of those. But if you're not, then just draw the picture and then just count. You know how to find the slope of a line. You just count, rise over run. That's how you find the slope. And I'll do it the counting method in a minute. Then we have the equation to find the foci. C squared equals a squared plus b squared. So the way I remember that with ellipses versus hyperbolas, it's c squared equals a squared b squared. But ellipses have a plus in between and we use a minus for the foci. Hyperbolas have a minus and we use a plus to find the foci. Okay, so that's how I remember it. I just remember that it's the opposite. Another thing is you can remember that your c squared value is always going to be positive. We're not going to give you an imaginary c. So if you have an imaginary number, you probably either flip-flop the numbers or you're using plus instead of minus or minus instead of plus. Usually minus instead of plus if that's the case. A, B, C, and D and the eccentricity, all of those things are the same. Distance to the vertex, the covertex, the focus, and then eccentricity is c over a. And for hyperbolas, e is always going to be bigger than 1. Okay, not something that you necessarily have to know. That is something that will always happen. But the eccentricity, same thing as it was for ellipses. It's going to be c divided by a. And that'll just help us. Sometimes the information is given, and you it helps you to write or find the c or the a so that you can find the b. All right, so the horizontal and vertical hyperbolas. Now, those vertical and horizontal dash lines, you don't have to have those. I just put them there so that you could see what the conjugate versus the transverse axis was. The parts that you have to have are the asymptotes. So those are those slanted lines that go through the center, the actual hyperbola, the vertices, the covertices, the foci, and the center. Okay? And again, a second ago I said it doesn't matter if A is bigger for hyperbolas. That's only ellipses. A is still the distance from the center to the vertex. It might be the farthest away. It might be the closest. It doesn't matter. Okay? And ellipses, we had major and minor axis. Those are the only conics that have a major and minor axis. Hyperbolas have a transverse and a conjugate, where transverse is the vertices. Does not mean it's the longer one. Okay, that's only ellipses with major and minor. Transverse can be the longer or the shorter. It just contains the vertices. So transverse has the vertices, and the conjugate is the other one. And really what the conjugate and transverse axis are going to help us do is to draw our asymptotes in a minute. Notice that the focus is outside. It's further away from the center than the vertices, which is the opposite of ellipses. Ellipses goes center, focus, vertices. Hyperbolas is center, vertices, focus. So that's one way you can tell the difference when you're given information, whether it's a hyperbola. If you're given the vertices and the focus, or a vertex and a focus, and the center, you can determine whether it's a hyperbola or ellipse just by the location of the focus. If the focus is closer to the center, it's an ellipse. If a focus is further away from the center than the vertex, then we know it is a hyperbola. So horizontal just means it opens side to side. Vertical means it's going to open up or down. All right, if you need me to come back to this so you can finish labeling it, I'll do that at the end. All right, so just like the ellipses, you're given an equation and you've got to fill in all the information. So this one's already in standard form. We don't have to do any kind of completing the square. All we have to do is look at it. So horizontal or vertical. We look, it's already in this first term's positive minus this, so we know it's a hyperbola. The first term is the y. Y changes vertically, so that's how we know this is going to be vertical. Vertical just means it's going to open up and down. Okay, so we know that when we graph it in a second. A squared is always first, so this is a squared, this is b squared, therefore we can find a. A is a distance, so it is not plus and minus 3, it's just 3. B is just 6, because it's a distance. And then c squared equals a squared plus b squared. C squared equals 5. So c equals the square root of 45, which can be simplified 9 times 5 to 3 root 5. Always simplify if you can. No sense in getting a point taken off for not simplifying. All right, we can find the center. Now remember, we get this, these can be a little bit tricky. This one, if you get them mixed up, doesn't matter because they're both 0, 0. But remember, we get the h from the x, we get the k from the y. So be careful with hyperbolas and be sure that you don't get the center incorrect. Because if you mess up your center, that affects everything. It affects your vertices, your co-vertices, your foci, your equation of the asymptote, the domain, the range, the graph. Everything from that point on is incorrect. So very important to get your center correct on these. The eccentricity we could find 3 root 5 over 3, which simplifies to root 5. And then the rest of it I'm going to find after I graph it. So I have a center of 0, 0. We know it's going to go vertical. This tells me I'm going to move vertically, distance A, from the center up and down. Then I'm going to move 6 left and right. So I'm going to move up 3 and down 3. And those are going to be my vertices. So the vertices are going to be 0, 3. And 0, negative 3. If you want to write those together, 0, comma, plus or minus 3, that's fine too. The co-vertices are going to move left and right. That's underneath the x, so we move 6 to the right and 6 to the left. And those are your co-vertices, which is going to be 6, 0 and negative 6, 0, or plus or minus 6, 0 would be fine if you like writing them together. Now, some of your teachers last year might have showed you to make a little box, okay? I'm going to make this little box. If you want to make it, terrific. If you're going to do it, be sure it's a dashed line. It's just kind of helpful to draw the asymptotes. If you struggle with the asymptote part of it, what it's going to do is just going to help you graph this. It's not necessary, but it's helpful. So what it's going to do is help me draw these asymptotes, because the asymptotes are going to go right through the center and out the corner of those boxes, or the box. Through the center and through the corners of the box. I have to draw the asymptote before I draw the graph. If you draw the graph before the asymptote, there's no way to know if you're really going to get it right or wrong, because your graph has to approach the asymptote. You can't just randomly sketch a little graph right there, okay? It has to approach the asymptotes. It's going to go through the vertex. Kind of looks like two parabolas. Parabolas have a vertex, so it has to go through that vertex. So I'm going to go through that vertex and go along that box and that asymptote and draw the hyperbola. It's going to approach that. Do not just draw that. You're not going to get any credit for that. You're not going to get any credit for something like that. You must approach the asymptote. So you must draw the asymptote first. That is the one thing that you must do before you draw the graph. The asymptote has to be there before you graph the hyperbola. And it needs to approach the asymptote. Very important that happens. All right, I'm going to plot the foci now. So 3 root 5. Now, this is where I go back to that root 45. Root 45, I don't know. But I do know root 49 is 7, so I know root 45 is going to be less than 7. Root 36 is 6, so it's going to be between 6 and 7. And it's always in line with the vertices. So 3, 4, 5, 6, and a little bit. 3, 4, 5, 6. Somewhere between 6 and 7, so there are your foci. You'll notice the further the foci are away from the vertex, kind of the wider the graph is. As it gets closer, the graph gets skinnier. So we can go ahead and write those. So we did not go anywhere, left or right, but we went up or down. So we could say plus and minus 3 root 5, or you can do those separate, 0, comma 3 root 5, 0, comma negative 3 root 5. I do not care if you write them separate or together. And then the equation of the asymptote. Okay, so the equation of the asymptote, if you look back at that front page, is y minus k. Well, it's 0, so it's just y. Equals plus or minus m, the slope. So if you look at the picture, we want the slope of these two lines. One of them's positive, one of them's negative. So up, rise is 1, 2, 3. Run, 1, 2, 3, 4, 5, 6. 3 over 6 needs to be simplified to 1 over 2. And then it's x minus h. H is 0, so it's just x. So there's the equation of the line. Okay, an asymptote is a line. Now, today's going to be pretty easy. Tomorrow, when we introduce the parabolas, it's going to look similar. The equation of a parabola is going to look similar to a line. But a parabola is squared. A line is not squared. So important to know the difference between the two. And then the last thing, the domain and range. Domain are the x values. We just look left and right. It goes left and right forever. So that's negative infinity to infinity. Range is up and down. It starts going down forever, and then it goes up to the vertex. So it goes up to negative 3 and stops, and then it skips back up to 3 and then goes up forever. So that middle section with all those dashed lines is not part of the actual graph. Those values do not exist on this particular graph. Questions? All right, the next one, we are going to have to complete the square. So our first step is to get everything matched up. So x squared minus 2x minus 4y squared plus 16y. And bring the constant to the other side. Since we have an x squared and an x, a y squared and a y, we have to complete the square for the x and the y. Our first leading coefficient's already 1, so we don't have to worry about factoring anything out. Half of b, square it, add it to both sides, so plus 1 on the left, plus 1 on the right. And now it's minus 4, so we have to take out a minus 4. And that leaves us with y squared minus 4y. That's the biggest mistake I saw last week when completing the square, is forgetting to factor out of that b term. Because if not, 16 is a really big number. Half of 16 squared, add it to the other side, you get some numbers that don't cancel. You know you've done something wrong. So 2 squared is 4. But since we factored something out, we have to multiply before we add it to the other side. So 4 times negative 4 is negative 16. So we have to add a negative 16 to the other side. If we put a negative 16 on the left, we have to put a negative 16 on the right. And then add those numbers and you get 4. Again, the point of completing the square is so that we can write it as a binomial squared. That's the reason. And now, again, we can tell from the beginning, up here, 1x squared minus 4x squared. The signs are different, so right there we knew that was a hyperbola. Today we know it's hyperbola because that's what we're learning. Thursday, you've got to be able to know that that's a hyperbola by looking at it. Hyperbolas must equal 1, so we need to divide everything by 4. And now we have standard form. Minus 1 squared over 4. 4 divided by 4, so it's just minus y minus 2 squared equals 1. So there is your standard form. Now you can answer all the questions about the hyperbola. So horizontal or vertical, the x is first, and it's positive. Again, if it's in standard form, we're going off everything off of standard form. The questions that I'm asking are off of standard form. So the x is first, so it's horizontal. A squared is always first, b squared is second, so a is 2, b is 1. C squared equals a squared plus b squared. So c is equal to the square root of 5. That can't be simplified. The center, 1, 2, bless you. We could go ahead and do the eccentricity, root 5 over 2. And again, if you want to come up with all the stuff and then graph it, you can do that, or graph it and then find the stuff. It's up to you. I like graphing it and then finding the stuff. So we have the point 1, 2 is the center. And we're going to move 2, because this is a squared, so a is 2. A is the distance from the center to the vertices. So we're going to move left and right. So we're going to move 2 to the right and 2 to the left, and that gives us our vertices. So negative 1, 2, and 3, 2, because it's horizontal, it's going to open left and right. Our b value is 1. 1 is going to move up 1 and down 1, and that gives us our covertices, which is going to be 1, 1, and 1, 3. If you want to draw the box, those corner points are kind of what is important. If you just want to make those points where it would meet, you can do that. The box is not necessary, but the asymptotes goes right through the corner, through the center, and through the corner where those two values would meet up. If you went up and right, up and left, down and left, down and right. And then we could draw, now that we have our asymptotes, we can draw our hyperbola. So because it got skinnier, our foci should be a lot closer to the center, and it's root 5, which is a little bit bigger than root 4. So it's going to be a little bit more than 2 from the center, a little bit more than 2 from the center. So our foci were at 1, and we went to the left root 5 and the right root 5. So 1 plus or minus root 5, and the y value did not change, so it stays at 2. We did not move up or down. We only moved left or right from the center. And if you want to write them separately, 1 plus root 5 comma 2, 1 minus root 5 comma 2, that's okay also. All right, equations of asymptotes. All we do are pull these out. So y minus 2. Just pull that y and x out of the center equals plus or minus. And now we find the slope of those asymptotes. So at the center, we go up 1 over 2, or up 1 left 2, so that's plus and minus 1/2, and then x minus 1. Those are equations of the two slanted lines. And the equation of the asymptote always includes the center. Now domain is left and right, so the domain goes from negative infinity all the way to this point right here, which is negative 1, and then it skips over to 3 and goes to infinity. And then the range is the up and down values. All the y values are covered, so that would be negative infinity to infinity. So on hyperbolas, either the domain or the range, one of them will be negative infinity to infinity, depending whether it's a horizontal or vertical hyperbola. All right, this next one we have to complete the square as well. So we've got to line everything up. 4x squared minus 8x. This one's going to be a little bit less work because there's no y, just a y squared. We bring that 104 over, it becomes negative 104. So we do have to factor out the 4 before we can complete the square. Don't forget to factor it out of the 8 also and get 2x. And then half of 2 is 1. 1 squared is 1. So we add 1 times 4 to the left, add 1 times 4 to the right. Then minus 25y squared equals negative 100. Now, let's look back at that top. 4x squared minus 25y squared. That's all. If I said, what conic is this? You wouldn't have to do anything. But look at these two terms, and right there we know that that is a hyperbola because the x squared and the y squared were different. If this had been a plus, now it becomes an ellipse. If this had been a 25, now it's a circle, okay, just by looking at it. Same number, it's a circle. Same sign, it's an ellipse. Different signs, it's a hyperbola. Okay, that's how you can tell the difference if you just need to name the conic. All right, so the reason for completing the square so that we can write it as a binomial squared. Now this equals negative 100. Oh, thank you. So we need to divide by negative 100. And you can just do one big negative 100. You don't have to do them all separate like that. So you get negative x minus 1 squared over 25 plus y squared over 4 equals 1. That's not quite standard form. Okay, we need the positive to be first. So y squared over 4 minus x minus 1 squared over 25 equals 1. Now it is in standard form. So now we can determine whether it's horizontal or vertical. Find the a squared, find the b squared. You can still find that stuff if the negative's first, but everything's flip-flopped. So always make sure your leading term is positive when you're writing it in standard form. All right, so now when we find all that stuff, because the y is first, it's going to be vertical. This is a squared, this is b squared. Hyperbolas, a squared is first, ellipses, a squared is bigger. So a is 2, b is 5, because those are distances. C squared equals 4 plus 25. So the square root of 29 can't be simplified. And then be very careful right here. Don't say the center is 0, 1. H still comes from the x. Y still comes from the k, so the center is 1, 0. If you mess up on your center, everything else will be wrong, okay? You cannot mess up on your center. It's very important, and it's very easy to do on hyperbolas because it's the one where they are flip-flopped. we could find our eccentricity, root 29 over 2. And then if we go ahead and plot this, 1, 0. So we're going to move A on the y-axis. Y moves up and down, so I'm going to move up 2 and down 2. Those are going to be my vertices, which is going to be 1, 2, and 1, negative 2. You could do 1, comma, plus or minus 2. It would work since we're at 0. The co-vertices, we're going to move left and right 5. So that's going to be 1, 2, 3, 4, negative 4, 0, and 6, 0. Those we can't write together. Okay, we have to actually write those separately. The vertices could be written together. The co-vertices cannot. They must be separate. 1 plus or minus 5 doesn't work. You know what 1 plus 5 is and 1 minus 5 is. You must find that. Again, if the little square drawing the box is helpful to you, go ahead and do that. It is not necessary. Just only if it's helpful, do that. And then your asymptotes must be dashed lines. And it's vertical. So we're going to approach those asymptotes. And then our foci are root 29. So that's going to be a little bit more than 5 because root 25 is 5. So from the center, 1, 2, 3, 4, 5, and a little bit. 1, 2, 3, 4, 5, and a little bit. And then we don't know exactly what that is, so we have to use the root 29. So the foci, the x value did not change, so it stayed at 1. But we went up root 29 and down root 29, so plus or minus root 29, because we started at 0. And then equation of the asymptote. We bring the y down. Y equals plus or minus. Then we find the slope. So again, I always like to use the picture. So I start at the middle and go up 1, 2. That's rise. Run is 1, 2, 3, 4, 5. So my slope is 2 over 5. And then x minus 1. It's the equation of a line that goes through the center. It's just point slope form. Our domain are the x values, which goes left and right. It goes left and right forever, includes all x values. It does not include these y values in the middle. So it'd be negative infinity up to negative 2 in union with, picks back up at 2, and goes to infinity. Okay, so again, on a quiz or a test, we might not ask you all those parts. We might just say, what are the vertices? Or write in standard form. Or what's the center? Or is it horizontal or vertical? What's the conjugate axis? So here, the transverse axis is this shorter one, and the conjugate axis is longer. Okay, it doesn't matter which one's shorter and longer for hyperbolas. All right, and then these last problems, okay? Center at the origin, vertex, and a focus. So right there, obviously today we know it's a hyperbola because we're learning hyperbolas, but on your quiz, vertex and focus and a center, right now we know that we don't know. That could be a ellipse or it could be a hyperbola. So we need to draw a little picture to see where the vertex and the focus are in relation to the center. So there's the center. Here's the vertex at 0, negative 12, and here's the focus at 0, negative 13. That right there, because the focus is further away from the center than the vertex, we know it's a hyperbola, other than the fact it says it's a hyperbola, okay? So we know it opens up and down, so that means our y value is first. Y squared minus x squared over something equals 1. This distance from the center to the vertex is a, which is 12. A squared's first, so 12 squared, 144. The distance from the center to the focus is c, which in this case is 13. So we have to use c squared equals a squared plus b squared. So 13 squared, 169, a squared, 144, plus b squared. So you subtract 144 and you get 25. So b squared is 25. If you get something negative down there, you have done something wrong. You've used the wrong equation, the wrong numbers in the wrong places. You will not get a negative value for a squared, b squared, or c squared if you're ever trying to find them. Questions? All right, and then the last one. Now I put a little grid here just because this one, when it gives you the asymptote, sometimes some of you can see the different, like 1/2 doesn't necessarily mean that the a and the b are 1 and 2. It could be 3/6 or 5/10 or 4/8 or 2/4. It just depends on the problem given. So we have a center at the origin. We still can't say x squared or y squared first because we don't know whether it's vertical or horizontal. It tells us we have a vertex at 8, 0. So 2, 4, 6. 8, 0. That's a vertex. What that tells us is we have a hyperbola that goes up and down. We're going to also have, side to side. We're also going to have one over here because that's a vertex. Therefore, we know that x squared is first, y squared is second, equals 1 because the center is at 0, 0. So we know that much. We also know the distance from the center to the vertex is a. So a is 8. 8 squared. So we can put 64 under the x squared. Now we just have to find the b squared, and that's where our asymptote is going to come into play. So the asymptote, it tells us, is 1 over 2. So up 1 over 2. Okay, but that's not where our box is. Okay, our box is somewhere out here. We just don't know how far up and down to go. So we just keep going. Up 1 over 2. Up 1 over 2. Up 1 over 2. Until we hit the vertex. Because that's going to be what makes our little box right there. Rise over 1. So we rise 1, 2, 3, 4. We run 8. 4 over 8 is equal to 1/2. What that helps us do, we already know that our a value is 8, but it helps us find our b value. Because from the center up to the covertex is our b value. So b is 4. So b squared is 16.